center of the circle. Now we're going to start talking about something called inscribed angles. And so the word inscribed means it's somewhere inside the circle. Crazy, right? But instead of it being at the center of the circle, it's going to be on the edge of the circle. So my first term is an inscribed angle. And it is an angle whose vertex is on the circle, whose sides contain chords of the circle. So if you take a look at this first picture here, my angle does not go to the center, so it's not a central angle. It goes to the edge of the circle. So here's my point C on the edge of the circle, and this is called an inscribed angle. The measure of an inscribed angle is half the measure of its intercepted arc. So that means if I look at this angle right here, if I trace the chords that make up this angle, and I follow these straight out, I get arc AB. And so this definition says, if I give you the measure of this arc right here, right? So let's say I tell you that this arc is, it's not, but let's say I say it's 100 degrees. The angle that's inscribed with that arc is going to be half of the arc itself. So if this arc is 100 degrees, I take half of it, that'll give me my angle right here. So what should your angle C be? It should be 50 degrees. It's half of 100. This angle right here is 50 degrees. And that's all that this theorem says. So if you take to find the measure of this angle, angle ACB, I'm going to take 1/2 of arc AB. Or in other words, I'm going to take the arc and divide it by 2. So half of arc AB. That's the same thing as saying take the arc and divide it by 2. Same thing. So if I give you this arc, you're going to divide it by 2 to get the angle. Now, if we go the opposite way, an intercepted arc has endpoints that are on the sides of the inscribed angle and all the points of the circle between them. So the measure of an intercepted arc is double the measure of the inscribed angle. So in this picture, I gave you the arc was 100, and we divided by 2 to get the angle. In this picture, I'm saying the same thing, but I'm going to go, okay, this time I'm going to give you the angle measure. I'm going to tell you that this angle this time is, I don't know, 30 degrees. What does that mean arc AB has to be? 60. You just double it. Exactly. And that's all that this definition says. That's all that an inscribed angle is. So if you multiply 2 times the angle ACB, you get arc AB. So in other words, you can go either way. If I give you the angle, multiply by 2 to get the arc. If I give you the arc, divide by 2 to get the angle. That's it. That's the whole definition. Nothing more, nothing less. You're either multiplying by 2 or dividing by 2. That's it. So let's take a look at an example. Okay, first one says, find the measure of angle ABD. So first thing I always do is I trace the angle that it asks me to find. ABD is this angle right here. And I always color it in. And then I follow my chords and I make straight arrows out so that I can see which arc it intercepts. So what's the arc that matches up with this angle right here, angle B? Arc AD. Very good. Now, I tell you what arc AD is. What is it? It's 196. So this arc is 196 degrees. How do I figure out what this angle is? Take half of it. Exactly. So to find angle ABD, I'm going to take half of arc AD. So in other words, I'm going to take half of 196. Or 196 divided by 2. Just take half of it. So what is half of 196? It's 98 degrees. Ta-da, and you're done. So angle ABD is 98 degrees. That was it. That was the whole problem. Nothing more. Easy, huh? Too easy. I kid. It's all gonna be easy. So if I give you the arc, divide by 2 to get the angle. If I give you the angle, multiply by 2 to get the arc. That's it. So you're just going forward or backwards, either multiplying by 2 or divide by 2. All right, next example. Find the value of x and arc ABD. Okay, so the first thing I give you is this angle right here is 70 degrees. Now, do just like we did before, follow the side lengths, follow the chords, and make arrows to see the arc that it matches up with. What's the intercepted arc that it matches with? Arc AD. Good. Perfect. Now, I've got a little bit of an equation here, though. I know my angle right here is 70, but I know that my arc over here is 7x. What should I do to try to figure this problem out? Okay, so we know that this arc in here is 70 degrees. If I ignored that for a second, right? Yeah. If I ignored this for a second, and you already know that this angle right here is 70 degrees, what does that mean this arc right here, AD, is? It's 140. I just have to double it, right? So I know arc AD is 140 degrees. Well, I'm just going to take this right here and set it equal to 140 degrees, right? And then I'm just going to solve it. So essentially, I'm taking 7x and setting it equal to 2 times 70, doubling the 70. So I'll write out 2 times 70 for the first one here. So I'm just setting 7x equal to 140 because I know this arc right here has to be double this angle. So it's an algebra problem. What should I do? Divide by 7, yep. What do you get for x? 20. Look through, you just figured out the first part. X is 20. If I plugged in 20, what should I get over there? 140, right? Double 70 should get you to 140. So now you figured out this piece right here. You know this piece is 140. You know that piece is 70. Fantastic. But it also asks me to find arc ABD. So arc ABD means you start at A, you go through B, and you end at D. So I still want to know this blue piece of the arc. What am I going to have to do to figure out that blue piece? Good. I know the whole thing is 360. I already have 140 of the 360, so ignore everything on the inside. You already have 140 of that whole thing. So to figure out what's left over, I'm going to take, sorry, this should be, to figure out arc ABD, I'm going to take 360, the whole thing, and subtract the piece in pink, and that'll give me what's left over in the blue. Yep, so arc ABD is 220 degrees. Don't forget the degrees, that's really important. And you're done. So you're kind of you're still using your intercepted arcs, but you also have to use that information of the whole circle being 360 to help you solve for the rest of the problems. Yes? Yeah, that's fine. What questions can I answer about that problem? Any yet? Okay, next one. Find the measure of arc AB and BC. Okay, so the first thing I'm given, I'm going to color in here, is my 16 degrees. That's what I know. And then I'm going to do the same thing I did before. I'm going to trace my chords and make an arrow to find the intercepted arc that it matches up with. So I'm going to trace the side, trace the side. Which arc does that angle match up with? Which one? Right here, B to C. Now, how am I going to figure out what that arc BC is? Yep, just double the 16. Exactly. And that'll give me this arc right over here. Exactly. So I'm going to do 2 times 16. I get that the arc is 32 degrees. Perfect. So you have this piece already right here. This is 32. Wonderful. Good. That's the first one. Or the second one, technically. Figured that out. Woohoo! Okay. Now you still have to figure out arc AB. So here's A to B. How am I going to figure out this one?
Subtract 32 from 180.
Is that what we're about to say? Yeah, exactly. This is half of the circle right here. Right? If I ignore the rest of this, that's half the circle. You already know 32 of this half the circle, which is 180. So to figure out what's left over, I'm just going to subtract the 2. So to figure out AB, I'm going to do 180 minus 32, and that'll give me what's left over. Degrees. That's 148. And guess what? You're done. Why are you making a face like that? What question do you have? So I've got I took the angle first with 16. I doubled it, and that gave me the arc right here of 32. That's this one, BC. How to get which one? 148. So then I said this piece right here is 32. I know that AC, this is a straight line, which means that's 180. You know 32 of the 180. And so to figure out what's left over, I'm going to take 180 and subtract 32. And that'll give me what's left over. So always look for a straight line. That'll give you 180. Good question. All right, any other questions? Feeling okay? All right, next one. Find the measure of angle BAC. Okay, so let's mark our picture. BAC. Trace it. Just like we've been doing. BAC, I want to know this angle right here. BAC. Which arc does it match up with? Well, what are the letters of the arc that it matches up with? B to C. Okay, so if I figure out BC, I can figure out what that angle is. And I got a little bit of a problem, right? Because I don't have anything yet over there in that picture. The only thing I give you is that A to B is 48 degrees. That's all I give you. What do you think we can do? Why'd you do that, David?
Because it's half the next circle.
Beautiful. This right here, David's going, hey, there's a straight line. That means this right here is 180. You already have 48 of the 180. So to figure out what's left over in the pink, we're just going to subtract the 2. So to figure out arc BC, we're going to do 180 minus 48. You get 132. Now that's great, but that doesn't answer my question. Because my question is find the angle BAC, which is this piece over here. How'd you get 66? Very nice. So this is the arc, the intercepted arc. It's 132. To find the angle that goes along with it, I just have to take that number and divide it by 2. So I get 66 degrees. So this angle right here is 66 degrees. So it's always looking for straight lines to be 180, or using that information that the full circle is 360. So sometimes you will have to find other things that are not asked of you before you can answer the question, right? It didn't ask me to find arc BC, but I had to figure that out first so I could answer the question. So sometimes you have to do multiple steps to get to where you want to end up. Okay, last one on the front. D6. Okay, we're good. Bless you. Bless you. All right. Find the measure of angle JLM. So just like before, let's start by tracing the angle that we want to find. JLM, and let's color it in. Here's the angle, JLM. And then what arc does it match up with? J to M. Good. Here's the arc that it matches with. Right there. Okay. So I either need to find the, I probably need to find the arc first before I can find the angle measure. Now, what's something that you see in this picture that's given to you? Vertical angles. Which ones are vertical angles, David? And the one right below it. Good. So David's saying, hey, these are vertical angles. These make an X. So since this is 88, guess what this one is? It's 88. Let's mark it in our picture. All right. What else do we know? The other two equal. And how did you get 92?
Add 88, subtract that from 360, and divide that.
Divide by 2, or what's a faster way to do it? Subtract from 180. Yep, either way is going to give you the same answer. So we know that this is half of a circle, 180. So to figure out what's left over right over here, I'm just going to subtract 180 minus 88. And I get 92 degrees. So angle P on the left and the right are both 92 degrees. So let's mark that in our picture. Okay, great. But now what? Divide what by 2? Why would I do that? Add what? Well, if I add them all together, what am I going to get? 360. Does that really help me get this little piece though? Well, if I subtract 88, 92, I'm going to get 180 because it's half the circle.
Would you do 180 minus 92 minus 80?
Then I'll get 0.
The arc measure is
Which arc measure?
J.
How do you know that?
And also if you do that 88 plus 88 plus 92 and then subtract that.
Okay, that's a lot more work, but yes. So here's what David's saying. These angles are different than the ones we've done because these angles before were all inscribed angles. These angles right here come to the center. That means they're called central angles. This is just like our warm-up problem. Anything that's at the center of the angle should be exactly the same for the arc right above it. So since this little angle right here is 88 degrees, what does that mean J to K is? It's also 88 degrees. Since this angle is 92, what's K to L? It's 92, and so on and so forth. So we know that JM is 92 degrees. I can use that information to figure out this angle L by doing what with the 92? Dividing it by 2. Exactly. That's going to get me my smaller intercepted arc. So remember, you still take the number on the outside, divide it by 2, and that'll give you your angle on the inside. So that's exactly what we're doing here. I know my arc on the outside is 92. I'm going to divide it by 2 to get my angle L. So if I divide 92 divided by 2, I get 46 degrees. So this small angle here is 46 degrees. So I had to use not only information about inscribed angles, I also had to use central angles to figure that problem out. All right, what questions can I answer about that one? Because I know that one was a little tricky. Yeah. Questions, comments, concerns. Not a single question. I'm that amazing at teaching. There's not a single question. Okay, flip it to the back. You're going to love the back side. It's way easier. Gonna love it, promise. Watch how easy this is. Okay, first one. Intercepted arcs corollary. What does the word intercept mean? Crosses. Okay. Where they cross over each other, they intersect, right? So if inscribed angles of a circle intercept the same arc, the angles are congruent. So in this picture here, I have 2 different angles. My first angle is CAD. This piece right here, so angle I. Which arc does it match up with? CD. So this one matches up with this arc right here, CD. There's a second angle right over here, angle CBD. Which arc does that one match up with? The exact same arc right over here. So that means those 2 have to be the same because of this. If I tell you that this angle right here is, let's say, 100 degrees, what does that mean angle A has to be? Nope. It's an inscribed angle, so it's got to be half of it. So what does angle A have to be? 50 degrees because it matches up. But what does that mean angle B also has to be? It's 50 degrees again because it matches up with the exact same arc. Right? So if they're both matching up with the same arc, well, then they have to be exactly the same. And look, a circle is exactly the same all the way around. It's equidistant. So it doesn't matter if I kind of move my angle a little to the right, a little to the left. If it's still opening up to the same spot, then those angles are going to be exactly the same. So here's my conclusion. Angle A and angle B are congruent. Right, angle A and angle B are congruent, and those are equal to half of arc CD. Put that kind of in parentheses. So angle A and angle B are congruent, and they're both equal to half of arc CD. They're exactly the same because they open up to the same spot. Okay, so let's watch how easy this is gonna be. Are you ready? Ready for easy? You're gonna love this. Okay. Here's angle A. Angle A is 33 degrees. What does it open up to? What arc? Arc DC. What does the measure of arc DC have to be? It's 66. It's double. Okay. Angle B opens up to what arc? Which one does it open up to? The exact same one. So what does the angle have to be? Oh, it's 33 degrees. There you go. Ta-da, you're done. Angle B is 33 degrees. And that was it. Told you it was going to be easy. So if you know one, automatically the other one has to be exactly the same. That's it. Okay, let's look at the next one. Find the measure of angle G and arc IF. So let's start with the angle we're given is 67. Which arc does it open up to? It opens up to IF, which means I can figure out IF by doing what? Yeah, multiply 67 times 2. That'll give me this arc measure right here. So to find IF, I'm going to do 67 times 2. I'm just multiplying it, doubling it. So it's this. Right, you can kind of see how the angle's opening up to it. All right, what's 67 times 2? 434. Okay, 134 degrees. So this arc right here is 134 degrees. Great, that's one part. The other thing it asks me for is angle G. So here's angle G. What does angle G open up to? Which arc? G, which one? FI, the exact same one. It also opens up to 134 degrees. What does that mean that angle has to be? It better be exactly the same as the other one because it's the exact same angle. So angle G is 67 degrees. That's it. That's the whole problem. So if it opens up to the same arc, well, then that angle better be exactly the same because it's opening up to the same thing. Told you back was easy. I told you. All right, questions there. Ready for the last one? Last one. Inscribed polygons. So inscribed means inside. What does the word what is a polygon? Do we remember what a polygon is? What am I listening to? Polygon. Do we know what a polygon is? Well, it can have 4 vertices. Oh my God, who's playing videos? Who is that? Daniel, is that you? Turn it off, man. Why am I listening to videos? Oh my gosh, we don't know what a polygon is? All right, don't tell people I'm your math teacher. Tell people that it's someone else. It's not me. All right, let me give you an example of a polygon. A square is a polygon. A trapezoid is a polygon. A triangle is a polygon. A hexagon is a polygon. It's a what? A rectangle is a polygon. What's a polygon? It's a flat shape. It's a 2D shape with straight sides. That's all a polygon is. Okay. Woo. Just a figure with some straight sides. That's all a polygon is. All right. So this theorem says a polygon whose vertices lie on the circle. So it's inside the circle. Opposite angles are supplementary. What does supplementary mean? Excuse me. What is it? Adds up to 180. You have to know that. It will not be given to you on the test, and they're going to use that word. You have to know that that means adds up to 180. Adds up to 180 degrees. So if you look at this picture, angles that are opposite or like across from each other should add up to be 180 degrees. So angle A and angle C are opposite. If you add angle A plus angle C, you should get 180. Same thing should happen if you go to the other two. If you add together angle B and angle D, you should get 180 degrees. In total, how many degrees will you get? 360. And it makes sense because it's inside of a circle, and a circle is 360. So if you add together angles that are opposite, it should be supplementary, should add up to 180. So let's do some examples with it. Two quick ones. First one says, find the value of x and y. So which one is opposite angle x? 85. So x plus 85 should give you 180. What are you really doing? Just subtraction. Yeah, subtracting, excuse me. So you get x equals 95 degrees. Just some subtraction. Okay, you can probably figure out the other one with a little bit of mental math here. What does y have to be? 100, exactly. 100 plus 80 gives you 180. There you go. You're done. Ta-ta-ta-ta, that was it. Easy peasy, right? Easy, easy. Just has to add up to 180. All right, so then what would I do for the next one? How would I set it up? $3x plus 6x equals 9x, and then equals 180. Good. So you're going to do 3x plus 6x equals 180. Like German said, that's 9x equals 180. And then what do you do to get the x by itself? Divide by 9. Good. X equals 20 degrees. Good. And then what about my other two? What's the equation? Yep. 4y plus y gives you 5y. Yeah, I'm not going to write 4y plus y. 5y equals 180. And then you divide by 5. Good. All right. We are done for today. Your only homework is to complete the crack the code from yesterday if you didn't finish it. You have to submit your work on Canvas. If you already did it, then you do not have homework. But if you did not finish that from yesterday, you need to finish and submit on Canvas. That's your homework tonight. Okay? Save that. You're going to need it for tomorrow.
Do you have time at the end of the day to go over the work I missed?